Just in case anyone watches this recording, you got to see my shirt. Woohoo. Good evening, Paul. How are you?
Very good, very good, very good. Hey, Paul.
Hi, Gary. How you doing? That was you, wasn't it?
It's Bill Lytle.
Maybe you didn't have audio hooked up yet when I said hi.
Oh, I think it's there now.
It sounds like it, yes.
Yeah. And a good evening to you also, by the way.
Thank you. So how is Joanne, Paul?
She's doing pretty good. We're gonna have some challenges, I'm afraid. I'm gonna be up at UC Davis for cancer treatment for a week or two. So, so I'm trying to work out where she's got the health care she needs.
Well, hello, Gerald.
Oh, what's that happened here?
Good evening, Mr. Hyatt.
Hello, Douglas. How are you, sir?
I are fine.
So I'm curious, Gerald, are you wearing the jacket because you're outside, according to your background, or you just have the heater off inside?
I have this temperature set low.
Oh, okay. Yeah, it is the peak hours at the moment, isn't it, for energy use?
Yep. How you doing, Paul?
Hi, how you doing?
How's your lovely wife?
Just as lovely as ever.
That's good.
Yeah, she's doing fine. She's in the other room.
That's good. That's good.
Good evening, Fred and Tim.
Hey, guys.
Right.
Hello, everyone. How's it going?
Good evening.
Oh, good. My puppet master is here.
You have your
Does he
hand
pull
up
your
his back
strings,
there,
Doug?
Tim?
What's that?
Does he pull
You
your
have your
strings?
hand up his back there, Tim?
I don't want to discuss where his hands are right now.
Well, I'm glad he's on the other side of the screen from me.
Exactly.
Oh, you left. I guess I do this.
Yeah.
Are you telling me this is a shield?
What was that?
You're telling me this is a shield I'm looking at? There's something between us?
I think that was a TMI comment.
Well, I'm going to say. Bill, you're a ghost on your backdrop there, which is okay.
You're on mute, Bill.
Let me cut the stage lights here.
Hey, Jerry, will you allow me to share screen a little bit later when we're ready for announcements?
Certainly. Oh, I've already set it up.
Excellent.
That's better. All right.
Isn't Peddler Hill a much better backdrop than having a look at my mug, though?
There we go. All right.
What are we drinking there, Doug?
Just iced tea.
Oh, yeah, sure.
Long Island.
Well, actually, check this out. Good tequila.
Iced tea, as in Long Island iced tea.
Oh, yeah, right. Then I'd really get through the performance really well.
Yeah,
Yep.
he could talk about all kind of lunar features. Man.
Well, in that case, I'll be the Russian
I've
judge.
hard enough time to. Ow! Oh, man!
Ouch, ouch, ouch.
No, I'm not drinking any alcohol. It's going to be hard enough to pronounce senologic features and sinuous rills.
Hello.
Yeah.
Hello.
Hello.
How are you?
We are all well. It's very good to see you, Olivia.
Yeah. Nice to see you guys.
Thank you.
Good seeing you too.
Yeah.
Except for Bill, it's not so nice
I
to see
haven't
him.
seen you in a while.
So I don't know if you all heard or not, Molly has changed gears. She is separating from UC Berkeley and headed back to Dayton, Ohio to finish her doctorate.
Oh.
Oh,
I don't know, difference of opinion or difference of scholastic requirements or something, but she's pretty excited about going back to Dayton.
oh. Very good.
What
As long as they have
university
internet,
is she
she
at?
can go wherever she wants.
Yeah, true story, Jerry, right?
What institution is she aligned with there?
Yeah, the Air Force Academy. She'll finish her doctorate there. She said
Oh.
about 18 months to 2 years to finish up.
Dang,
Your PhD in astrophysics.
very nice.
I have a question for all you guys. If I'm looking for a telescope, what starting off beginning telescope, what kind should I get?
Ooh, that's a tough question, Olivia.
A 24-inch, no.
I'd start with something round.
Yeah.
You need to be able to move it around.
Okay.
Yeah, that's probably the
An
bottom
easy
line,
one
is being able to move
An
it.
easy one to move around is the 6-inch Orions that, do we have a 6-inch Orion she could try out or something?
Oh, well,
One of the Dobbs that we hand out?
That's interesting. Maybe we could come up with some solution to that.
That'd be a Jeff question.
Yep.
Yeah.
okay.
What's that?
And where the heck is Jeff when you need him?
Hmm.
I
Olivia,
don't know.
He's probably
We
hiding
do
in our
have-
telescope.
Olivia, there are a couple of YouTube videos that
Yeah.
describe some of the important things to look for in buying a telescope and what not to
Yeah.
get into. I will share those YouTube videos with you. I believe I have your email address. If not, maybe Jerry will
Yeah.
with me somehow and I could
Okay.
forward those.
Yeah. That'd be
YouTube-
nice.
Okay,
That'd
I'll
be
do that.
excellent.
I'm
Yeah.
thinking AstroScan would be nice and easy to use too.
I
Yeah.
was about to say, don't we have an Astroscan that's available?
I don't know if it's available, but we do have one.
I tried out one. I tried one out. I can't remember what it was.
AstroScan is the one with a little ball at the end. It's red.
Oh yeah. I did.
You
I
tried
did
that one
like
already?
that. I did like that.
That one's
Well,
easy to move
Just
around.
move you up to one of the
Yeah.
small knobs and then see which you like better.
Okay. That'd be fantastic.
Yeah,
Thank you.
you're welcome. We'll mention it to Jeff when he shows up. He knows
Okay.
what's available.
Just remember, a telescope is like motor vehicles. They're
Yeah.
designed for different things and have different strong points and weak points. And one thing I suggest is go to star parties, see what they're using, see what will work for you.
Okay.
Yeah, the other thing they
Okey-dokey.
have in common is they don't have carburetors anymore.
Yeah.
Olivia, do you have a place at home you can view from your backyard or? a
Yeah,
something?
yeah. Not too much noise. It's pretty light outside. I need to be a darker place. But in backyard, it could be, it's a little darker there.
Mhm.
That's what everyone says.
Yeah.
Pretty dark.
Yeah. Yeah.
We say that up on Peddler Hill.
I think the only person, a member of the club that's got really dark skies is Don.
Yeah. Yeah.
I see a couple of
Hello.
new names, guests. David Gray, glad to have you join us this evening.
Oh, yes.
Guillermo Jimenez.
Here's, yeah.
Hi.
Hi, thank you
Hi.
for joining us.
Hey,
this evening.
Guillermo.
Hi. I'm trying to get my camera to work. It's a brand new camera. I don't know. It looks like it is working, but I don't see my image.
Oh,
We don't see your name either.
Maybe I'm a vampire. I just didn't know.
another vampire astronomer.
I should know something, right?
What a better way to spend all your nights.
Hello.
Now, Guillermo, have I met you before?
Not sure.
Have you been up on Peddler?
No, I never been to a meeting.
Oh, okay.
I've been a member.
Star party?
I've been a member for about a year and a half, but I have never been to a
Oh,
meeting
okay.
after this started. Then I was supposed to go on vacation and then come back and start my astronomy journey, but yeah, there were other plans for me.
Okay.
Well, David, is this your first time here?
Actually, over Zoom, yes, but I was in the society for about an entire year during 2019.
Oh, okay.
I was with Dave Corder.
Ah.
So I just 2020 was rough.
That's what everyone's saying.
Yes.
Yeah.
Ready to
Yeah, would not recommend that year.
No.
Gave it 1 star.
No.
Hi, Maria.
Hi, Maria.
And I see Ray and Nihar and Neil. Welcome, everybody.
Nihar, are you going to join us on camera?
Yeah.
Hi, everybody. I was muted.
I've never done that before.
That's another one of those. It's new to 2020, you know.
Yeah, yeah. I'm muted. And Bob with the kitty condos there.
Yeah.
Yes.
Kitties are asleep. No, actually, they're washing. They just finished their dinner, so they're all happy.
Very nice. Hey, sun came up where Bob is. I mean, Bill is. Sorry.
Yeah, I had to turn on the ceiling light. I'm trying to see my paperwork. I'm trying to do work at the same time, but I'm sure that once the speakers get going, I'll be enthralled, you know?
I'm not sure
No pressure, Doug.
Nice of you to lie to me. I love that.
I do my best thinking with my head popped over.
Yeah.
Well, until then, Bill, you've got some great effects going on.
Yeah.
Yeah, I'm kind of tripping on those myself.
Yeah, pretty interesting.
You're transparent.
Yeah, I'm kind of jealous, actually. I recognize that telescope, though.
Okay, so I've got a question for you guys, but Jerry, Fred, and Doug, you cannot answer this. Who knows what March 20th is?
The day after March 19th.
Oh,
Very good.
That's a good one.
And a few days after St. Patrick's Day.
Yeah.
okay. You guys are close. What is March 20th?
I know.
Isn't that when they launched one of the Apollos or something like that?
You know, it could be an anniversary of the Apollo. That's what I wasn't going for. Think about our seasons.
It's crossover day.
It's March.
Yeah,
It's spring solstice.
vernal equinox.
Or vernal equinox.
You're absolutely correct. The vernal equinox.
So then it's not the Ides of March either, huh?
It could be.
No worries about getting stabbed in the back on that day.
Can't say that.
You're a former world leader.
Well, I mean, you know, if you're Julius Caesar, possibly you probably had one of the better deaths along with the early Roman emperors. So,
As opposed to drinking hemlock or being poisoned.
I was waiting for that caveat. One of the better deaths.
Eric.
Good evening, Eric.
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 Hello, how you doing?
It's just like Cheers, isn't it?
Yeah.
Where everybody knows your name.
Eric, where's your mask?
Where's my mask?
Yeah, your mask.
Oh, yeah.
No. Your alien mask. Your alien face that you had from a couple weeks ago.
I don't have it currently.
Oh, too bad. That was good.
I thought you said the eyes were bothersome.
Yeah, they were. They looked artificial.
Yeah, make up your mind, Fred.
Sorry.
you know, this is enjoyable. I've just all day today, I've just been having test anxiety for April and it's just like, although the good news is that if I get into my master's degree program, I'll be going in for theoretical astronomy and astrophysics.
Oh, very nice.
All right.
Bad news is it's time to everybody stop talking and open your test booklet and pull out your number 2 pencil.
You're giving me anxiety, Jerry.
That's my job.
Well, the place I'm going to is CSU Northridge, and they have the San Fernando Observatory up there.
Yeah.
And I'm hoping that I'll be able to do some research up there. So.
Do you have a particular field in mind?
Yeah, I'm going in for physics.
Oh, I mean narrower. You said astrophysics. Are you looking at like maybe galactic centers, black holes?
What? My refracting unit.
Hello, Jeff.
Hey,
Hi.
Hello.
how's the squid doing?
The squid is up and running. I'm gonna be out of the loop for a little while. Cancer treatment up at the UC Davis.
You're going to be there overnight?
2 weeks.
You're going to be there for 2 weeks?
That's what they told me.
Wow.
It's just one night. It'll just seem like 2 weeks.
Well, I'm wondering if they're doing an outside sort of thing, because I can't imagine them keeping me in there and all that. It's just something that has to be done. I do have to make sure that Joanne's covered and all that for dialysis.
So this is you going in Davis or Joanne going in Davis?
Oh, me.
And so
on the side of my head.
Yeah.
Yeah, they're gonna have to go. It's gonna have to be removed surgically and around the jaw thing. So it's just something I gotta do, make sure my wife is safe and make sure that I'm gonna be at the telescope very soon after I get out.
Who's going to be with Joanne while you're in the shop?
We're working on the details. It's probably going to be her son, which lives in San Jose. He should be able to get the time because the dialysis is very complex and very physically demanding.
Well, good luck, buddy.
Yeah, good
Thank you.
luck.
I appreciate that.
Good luck.
And
You'll be all right. She'll be all right. We'll be laughing about it this summer.
That's what happens when you're a squid.
That's right. It's all those tentacles.
That's what it is.
And little nematosis in there.
Yeah, they probably figure I got too many of these.
Serves you right for taking down that ship.
Our own Kraken.
That's how we named him. He's got a picture of him hanging over a telescope. I said, that looks like a giant squid taking down a ship.
A Kraken.
It cracked me up. I was working in the hobby shop in a selling telescope, and so we worked with got a picture of me leaning over a telescope fired. Well, Jeff had a real good time with that, and I was kind of stuck.
Remember when we did our Mercury transit at Sierra?
So I did.
Paul?
Yeah.
Remember when we did that Mercury transit at Sierra High School?
Oh, of course. Had a ball doing that.
Well, this last Mercury transit that just happened is the last one we're ever going to see.
That's true enough.
Hey, Mike. Hey, Jeff.
Hey, how you doing?
Hello, good, Jeff.
Hi, how you doing?
I don't know if they can hear us.
Oh yeah, I'm doing really well.
Where are you working?
I'm currently a substitute teacher, but like I was telling everybody, I'm hoping this year I get into CSU Northridge to get my master's degree.
All right. In physics?
Yep. And I'm going in for theoretical astronomy. I don't really know what I want to do with that yet, but it's at least a start, and and hopefully I get to go to the San Fernando Observatory to kind of do some research.
Oh, yeah.
So
What college you going to be at?
CSU Northridge.
Oh, yeah.
That's a good school.
I got some friends that went there.
Well, that's exciting.
Yes.
You're going to be hanging out at Griffith.
Yep. Hold on.
pretty bad. The only thing I can see is somebody in your ear.
Hello, Tom Palmer. Good to see you joining us tonight. Hey, there you are, Tom.
Hey, Tim.
Hey, you've been out observing any at all, Tom?
Excuse me?
Have you been out observing much?
No, not too much. Kind of chilly.
Yeah. A few of us were up at Highway 4 last Saturday evening and had a real good night, actually. The skies were nice. It was a little chilly, and then about 10 p.m. or so, the wind did come up, so it scared us off.
That's what I was wondering, if anybody had gone up there to 4. Notice that I drove by it today and somebody left a big old pile of garbage up there. Somebody used it as a dump site this weekend or something.
That's a bummer. How are you, Bill?
Doing just fine, thank you. How about yourself?
We missed you the other night.
Yeah, I was wondering if you guys were going up. I kind of, I was going to go up, and then I saw the wind coming up, and I said, screw that, take it right in the face up there, on Highway 4.
Well, we were up there and got the 32-inch setup, and I forgot my SIPs, which means the telescope couldn't focus, and we ended up tearing it down.
I understand
It's almost like somebody going up to Iron Mountain and leaving their ground board at home.
That hurts.
Who the hell would do that?
Forgetful astronomer.
Yeah, I was still here. I was at home, so I can't take credit.
How you doing, Bob?
I'm doing good. How are you?
I'm doing good.
Just having a little dessert right now. It's nice.
Did you bring enough for everybody to share?
Well, it could be virtually. I'm not sure how that would work, though. But it is good.
It looks good.
Cool. Hey, Paul.
Jeff, Mike, Eric, how are you guys?
Hey.
All good.
Hope those videos were
Doing
worthwhile.
well.
I don't know if that last one helped or not.
I didn't look at the last one, but I looked at the other ones.
Okay.
So
No,
I'm a student, and this is just going to take me some time, but I'm getting there.
if that doesn't work, we'll get on the phone and we'll figure it out.
Okay. I'll look at Eric's suggestions tomorrow when I'm less tired, and then we'll take it from there.
Eric has solved every problem I've given him. Every one.
I didn't solve your original
Okay.
motor system there. What was it? The CAT system?
Yeah, the Fusion 3.
Oh, the servo crap.
Your first gen ever made version.
Yeah, I don't do servo kind of more. The sidereal texture doing the trick though. But I was able to make a meniscus mirror on Fusion, but I couldn't figure out how to stick it to my cell. So then I said, well, let's start with the cell and then I'll worry about sticking the mirror to it. And there's something about a curved surface trying to mate it to something else. I haven't figured that out yet.
All right, gentlemen, it's past 7:30. I think we should get started. Fred, you're here, right? I guess he's here.
Fred is here.
Was.
All right. All right. Very good. Okay, so anyway, welcome everyone to the March 2021 Stockton Astronomical Society meeting. This is going to be a local presentation tonight with some of our best in the club speaking. No humor here, please. I'm saying this seriously. Okay. Fred, you want to go ahead and get started? And I think we should probably go ahead and have our presentations first, and then there's maybe a little bit of business to talk about.
Yeah, absolutely. I mean, to go and recruit, high power professionals, PhDs and others is quite the task. And we've had quite a lineup over the past 30 months or so. But to have people that are passionate about the hobby, the word amateur in French means to love. And so we have a bunch of amateurs here that love astronomy. And Tim and Nihar and Eric have graciously stepped up to the plate to talk about some of their favorite subjects. And so we're going to start off with Tim about lunar geology, and then we'll talk about Nihar and talking about the Perseverance lander, and then Eric is going to finish it up talking about contacts with extraterrestrials. So with that, Tim, I'll turn it over to you.
Okay, very good. Let me share my screen here with you folks. And then at the end, Mike, I do have a couple of slides for announcements. We want to get to one special announcement as a memorial at the end. Make sure we fit that in it as we get there, okay?
Just a quick housekeeping thing, Tim. Jerry, can you mute all the microphones except for the speaker, please?
I can mute everyone, and then the speaker will have to unmute themselves. Give me a moment.
There we go, Tim.
Okay. And Doug, unmute yourself as well. So.
All right, I'm on, I think.
Okay.
Everybody
can you see my opening slide there?
All right. Tonight we are going to discuss, I was going to say geologic features on the moon, but geo means Earth. So we're going to be talking about seismologic features on our moon. Hey, I learned a new word. So we're going to be looking at sinuous rills on our moon. Cue up that next slide there for us, Tim, I think. Tim?
I'm working on getting them to advance.
Okay. There we go. All right, everybody see that snake-looking object there in the middle there, snaking right past that thing? That is a sinuous rill. So sinuous is just a fancy word for snaky. Oh, go back one. For snaky or curvy. And rill is just a fancy word for groove. It's a German word for groove. So like a real groovy dude. Hit that next slide. Nope, not that one. Wrong one. Oh, well. No, there you go. Real tubular, dude. All right. So what are sinuous rills? So we're going to have to assume that these sinuous rills, these are just lava tubes, collapsed lava tubes, like we have here on Earth. We've got plenty of examples here. I have been in some in Northern California and in Idaho, and there are also some in Hawaii. And there's a picture of Hawaii with a nice big lava flow. And that is how these things are created. So on the moon, you don't have active volcanoes like we have here on Earth. There are some volcanoes, extinct volcanoes on the moon. But what we think most of these things happen on the moon were impact craters that broke the crust, filled up with magma, and then flowed out the side maybe. And so you have this lava flow and this molten rock or magma. When it's under the surface, it's called magma. When it's on the surface, they call it lava. It's the same stuff. So these liquids move downhill. And as it's moving downhill, when it's thin, like, thin pancake batter, and it moves downhill, the top layer starts to cool and crusts over. and forms this hard crust on top, and basically puts a nice insulating cap on top, and the magma lava still is flowing out underneath this hardened top and keeps running on down the hill. And as the crater empties of its molten magma, that thin gooey moon goo keeps flowing through the tubes until it runs out, and it leaves a hollow tube. Next slide there with the lava tubes. Nope, next one. There you go. So in Northern California, you've got the Lava Beds National Monument. As I said, I've been there, and you have these tubes that are left there, and you can walk through them and so forth. Kind of cool. There's lots of them in Idaho that I've been through. They are really good and well insulated. The ones in Idaho have ice in them all year round. So what is this moon goo that's gushing out over the thing, this molten magma? It's what we call basalt. And the question is, can we see basalt on the moon? Yeah. Next slide, Tim. There you go. So those big dark circles there you see, those Maria, Sea of Tranquility is there. You got the Sea of Range, Sea of Crisis over there. That is all basalt. And same basalt that we have here on Earth, like you see in Hawaii and so forth, that dark volcanic rock. Only difference between moon basalt and earth basalt is earth basalts have a tendency to have a lot higher iron content. But basically, if you're just looking at them, you got the same stuff. So next thing, there you go. So what would a former troglodyte be looking for a lava tube or a new cave on the moon for? Why would we be doing that? Well, to answer that question, let's go to the brains of this dynamic duo. Professor Trim, that's your cue. You are up, sir.
Okay. Yeah. Well, the two half brains maybe make a whole one between you and I, right, Doug? So that's what you get with these volunteer presentations. But we found this interesting, that these rills, these lava tubes, this volcanic activity on the moon really provide an opportunity in the future for us. And so what the Lunar Reconnaissance Orbiter has spotted here is in the Sea of Tranquility, the skylight. And this skylight is a crater, a hole in the top of one of these lava tubes. And so clearly you can see down into it. You can see the boulders down on the bottom of this crater. That's the interior of the lava tube that with the sun angle and the camera angle, they were able to photograph this and then measure it 100 meters wide and 100 meters deep. So these lava tubes and these openings, these skylights are pretty large. They can be exploited to be used as entrances to those lava tubes, so that, as you've heard, our plans to establish bases on the moon, lunar bases, are going to have many advantages as we go to explore the solar system and to launch expeditions to other planets. The advantage of setting up bases on the moon, mining the resources, in situ resource utilization, it's called, where future astronauts and explorers that are on the moon will be able to mine the resources. There's water, and from water you'll be able to break it down into oxygen and hydrogen, as you recognize as rocket fuel. And then there's a lot of minerals and metals on the moon. There's iron, as Doug mentioned, titanium, aluminum, another rocket fuel, silicon, magnesium, calcium. And so This slide here is a artist's rendering of a lava tube entrance that could speculatively serve as a natural shelter or habitat for future explorers. So the next slide here shows an entrance built over one of these lava tubes, either the skylight or some kind of other entrance with an airlock and a way to protect the lunar explorers as they go into these lava tubes. And so, as Doug mentioned, why would a caveman, why would an astronaut with all this technology want to go underground on the moon? Their whole object is to explore the moon. Well, remember that the universe is trying to kill us. It's not trying, it will succeed given any opportunity at all. Because any place other than Earth, we're not inside this cozy magnetic field or this atmosphere that we so much take for granted, but are protected by. You know, the radiation levels on the moon are like 200 times that on Earth. So instantly cause you all kinds of biological problems with these high energy particles like UV, X-ray, gamma rays, all kinds of hazardous exposure if you're going to be out on the surface of the moon. But go into these lava tubes where you're protected by this basalt and the crust of the moon. You're also protected by the micrometeorite impacts that are constantly bombarding the moon's surface. You know, the Apollo astronauts had special suits to protect them. The vehicles that went there had shields on them, protect them from these micrometeorites, and then these high energy particles. I was reading and listening to a story about some of the astronauts, the Apollo astronauts came back and they were telling stories of how they would see flashes of lights when their eyes were closed. And they figured that that was these high energy particles hitting their optic nerve and activating it. So they just penetrate right through your body. Other aspect of the hazard on the moon is the lunar dust. It's not like our dust on Earth here, which is fairly benign. It's, you know, dead skin particles and dirt and debris, and from but the lunar dust is like shards of glass from these micrometeorite impacts over billions of years, just create this really coarse, sharp dust that is really, really fine, and it gets into everything, into your lungs, into your spacesuit, into the machinery, anything that has a bearing. We've got to seek some shelter from all these hazards on the moon if we're going to have some success of establishing a base. And then naturally there's those gigantic moonworms that we've all heard about and fear so well. And so it's kind of ironic that the history of mankind came from cave dwelling. It has gone through all this technological advancement, and it's going to turn us into cavemen again, living in these underground shelters. And so we're just about to conclude here, but I found this great presentation here of a video that I want to share with you by Dr. Pascal Lee, a PhD with the co-founder of the Mars Institute and a planetary scientist with the SETI Institute. He's the principal investigator for the Houghton Mars project at NASA Ames in Mountain View. And I hope you enjoyed this. It sheds some new light on the research and the little bit of speculation that he's doing on how these lava tubes will come to service in the future. So let's see if this will play here. Give me just a moment. I believe the video is starting. It went so well in rehearsal, didn't it, Doug?
It worked last night.
Why don't you try closing it, stopping your share, and redo it?
Okay. Stop my share. Okay, let me try this again here. I apologize. I'm not sure why I'm not able to get it running here. Cannot play media. Okay, well, I'm having technical difficulties, so I will have to apologize for that and just summarize that this video from Dr. Lee illustrated some of his research of how he found these skylights on the moon that were at one of the poles that had evidence of water in it. And so his concept was to be able to utilize the water in the regolith there on the moon for all kinds of different purposes. And then he also was identifying the similar features on Mars of rills, lava tubes, and skylights, similarly for exploration of Mars. And then they speculate and even have evidence that these lava tubes exist on other planets as well. So the evidence is that we'll be able to utilize these for future space exploration. And that is really what Doug's and I presentation was about this evening. And again, I apologize for not being able to share that video with you, and turn it back over to you at this point, Fred.
Thanks, Tim, and thanks, Doug. No worries on the technical. There'll be more appropriate times when we can still come back to that. But I do have a question. In your research, either for you or Doug, when you research the skylights and the gentleman, the PhD gentleman who's doing the work on it also, is there any similarities to the skylights found on the moon and those large skylights found, and I'm using the term skylights in quotes, found in the northern Siberia region of the Asian continent here on Earth?
I'm not sure I know which ones you're referring to tell you the truth. That's.
You do or don't?
I do not. I'm not sure what you're referring to.
Do you know what I'm talking about, Tim?
I've heard of these skylights in all different places. I don't know specifically ones you're mentioning though, Fred.
Okay, no worries. All right, for the audience, any questions for Doug or Tim? Okay, very good. All right, thank you, guys.
Gee, we stunned them, Tim.
I guess so.
All right, moving on to our next speaker, Nihar, our youngest member of the board, is going to talk about the Perseverance lander on Mars. So Nihar, turn it over to you.
Okay. Oh, giving you a little preview. Okay, so I'm presenting on how the Perseverance Mars rover is different from other Mars rovers. First of all, what is a rover? A rover is a wheeled vehicle that goes on the surface of planets in space and it collects data about them. It also collects samples to send back to Earth for scientists to study. There have been 4 rovers before Perseverance. Sojourner, which launched in 1997, Spirit and Opportunity, which both launched in 2004 and were twins, and Curiosity, which launched in 2012. They were all launched within the last 25 years. What is the Perseverance rover? The Perseverance rover is a new Mars rover that launched on July 30th, 2020 and landed on Mars almost 7 months later on February 21st, 2021. Perseverance carried a drone called Ingenuity, which is the first drone to fly on the surface of Mars. Dimension. Perseverance is about 10 feet long, 9 feet wide, 7 feet tall, and it weighs 2,260 pounds, almost as much as a Honda Civic. Perseverance runs on nuclear power, with plutonium making up the light bulb inside, and it heats up and lights dark caves or spots on that is a typo. Okay, NASA started the Perseverance project in 2013 and finished in 2020. Perseverance is made out of aluminum, titanium, and gold. What is the mission of Perseverance? Perseverance has tools to detect signs of life on Mars when it was covered in water. It also can bring back more rocks for geologists to study. It's going to test a method for producing oxygen from the Martian atmosphere, and it identifies other resources such as subsurface water on Mars. It also can categorize weather, dust, and other potential environmental conditions that could affect future astronauts living and working on Mars. So basically Elon Musk's Mars bases. So I just put some heads on the team that built Perseverance. The real team is much, much longer. So the head of the entire mission was Swati Mohan, and the project manager was John B. McNamee. And the deputy project managers were Matthew T. Wallace and Jennifer Trosper. And the advisor to project management was Gun-Xing Chen. Where did they launch Perseverance and why? The Perseverance rover launched aboard a United Launch Alliance Atlas V rocket from Space Launch Complex 141 in Cape Canaveral Air Force Station in Florida. NASA chose this spot for liftoff because the Cape Canaveral base in Florida is bigger than most other bases around the nation and could supply Perseverance with the care it needed before liftoff. But it also can provides an advantage for rockets because it provides rockets with an extra boost because of the Earth's rotation. How is it different from other earlier rovers? Sojourner. Sojourner was the first wheeled vehicle on another planet and analyzed the rocks of Mars. Opportunity. It began traversing the red planet in search of signs of past life. The rover is still actively exploring the Martian terrain. Spirit. It is Opportunity's twin rover and went to Mars for the same purpose as Opportunity did. Curiosity. Curiosity's ongoing mission is to study the ancient habitability and the potential for life on Mars. All of these rovers are different from Perseverance because Perseverance is better equipped with modern tools to do what past rovers could not, to prove whether or not there was ancient life on Mars and if astronauts could survive there. Technical differences between Perseverance and past rovers. Perseverance was 9.5 feet, 8.9 feet, 9.5 feet wide, 8.9 feet long, and 7.92 feet high. Curiosity was the same measurements. And Spirit and Opportunity were 7.5 feet wide, 5.2 feet long, and 4.9 feet tall. Sojourner was 1.57 feet wide, 2.13 feet long, and almost a foot high. What has been achieved with Perseverance so far? Perseverance has successfully landed on Mars with Ingenuity, making it the first flying drone on the surface of another planet. Perseverance is currently collecting rock samples and placing them in the Jezero crater so that future missions to Mars can pick the rocks up and take them back to Earth to be studied. Perseverance is also scanning the surface of Mars for microbial life, remnants from when Mars was covered in water. And that's it.
Oh, that was great, Nihar. Questions of Nihar.
Good job, Nihar.
That was really good. Questions of Nihar. I have one, but I'll go last. No questions of Nihar? So Nihar, I have a question. Is it true that Mars is the only planet in the solar system populated by robots?
Yeah.
All right, very good. Okay. Thanks, Nihar. That was really good. It's amazing how we started out with such a small robot, and now we have this monster thing. It's the size of a Honda Civic. Wow, it's pretty interesting. Hey, real question though, serious one. I read that Ingenuity is going to fly somewhere around the middle of this month. Do you have any updates on that?
I'm not sure if I do, but I'll update you if I haven't.
Okay, sounds good.
All right. Hey, I have a question, Nihar. How long is Perseverance supposed to roam on Mars? Is it got batteries so it will eventually die?
I mean, it runs on plutonium, so it's obviously going to last a really long time. So Curiosity also runs on nuclear power, and it's been running for 8 years.
Wow.
Probably a really long time.
Other questions of Nihar?
I just have a comment. Looking at the APOD picture from the other day that showed a beautiful 360-degree scan, it looks like there's just boulders everywhere. Like, can you conceive of some way that boulders are just raining from the sky? Wouldn't that be crazy?
Yeah. I mean, on Neptune and Uranus, I think it rains diamonds.
Oh, there you go.
Yeah.
What do you use for an umbrella?
Yeah.
Fingers.
Okay, very good. And now on to our third and final speaker, Eric Holland, is going to talk about contact with alien life and the effects of that. So Eric, we'll turn it over to you.
Okay, I hope you guys can hear me okay.
Sounds good.
Before I really get into the meat and potatoes here, Tim, if you want to try and get your video to work on your machine while I'm talking, I think we could probably squeeze in time to play it at the end of my talk. Just a suggestion.
Okay. Yeah, I've been trying and I think I've got it queued up. So I'll take you up on that when you're done, Eric.
Okay, very good. Well, good evening, everyone. As Fred said, I'm Eric Holland, and I'm the current secretary of the Stockton Astronomical Society. My talk tonight is on the topic of the challenges of space travel and the difficulties in contacting another intelligent species. And this talk probably deserves at least a full hour, but I'm going to try to do my best to squeeze it into about 20 minutes. And I have a couple images to share at the end of the talk. I don't really have any other content to share, so just sit back, relax, and listen, or go to sleep, or whatever you choose. So here we go. Let's begin by discussing the challenges of space travel to start. The most obvious challenge is that space is really big. Ideally, we want to be able to travel to the vast distances of space as quickly as we do with planes and trains here on Earth, but that's not going to be very practical, like we see in science fiction, or they have light speed or warp drive engines. Unfortunately, that's just not close to reality. So what is really holding us back? It is mainly propulsion. To date, the primary source of propulsion is still chemical fuels. And since there is no Marvin the Martian quick fuel stop in the middle of space, it's going to be necessary to take all the fuel that you think you will need for your trip with you. Again, that's not practical. So the design of your spaceship, would need to be oversized to hold all the fuel. And as you consumed it, you're going to be left with a whole lot of empty storage space. But we do have scientists and engineers working on other propulsion methods, like the ion drive. The ion drive uses an inert gas like xenon, and the way it works is not dissimilar to old school cathode ray tubes, TVs. You're basically ejecting charged particles like electrons into space to provide a very small thrust. It's on the order of about 0.1 pounds. And over time, the thrust or acceleration keeps adding and building onto itself. And you start out going very slow, and it ramps up to a top speed. And to slow, you need to send the electrons in the opposite direction so that you can begin to ramp down. And overall, the process can take a fairly long time, but it's still much faster than going at a constant slow speed. And there's also other propulsion methods like fusion propulsion. If you were to compare the speeds between the chemical propellants or fusion, it'd probably take roughly 50 to 70,000 years to get to the nearest star, like Proxima Centauri, that's about 4 light years away. With a fusion propulsion, it'd be about 100 years. I'm not too sure exactly how long it would take with an ion drive, but regardless, it's going to take some time, and it's just not very practical. So even with an ion drive or any of these propulsion methods, traveling out in the middle of the Milky Way galaxy would be a huge feat. To do so would require a multi-generational trip. It would require many generations of family acting as crew. Most who are born, live, and die on board the spaceship. All the complexities of daily life would need to be dealt with on ship. Things such as growing food, obtaining water, dealing with waste, carbon dioxide buildup. People are going to get sick. Do you have enough medicines? So health is a crucial problem to solve for space travel. Once you leave the protection of Earth, like Tim and Doug mentioned, you leave the protection of the magnetic field, you're susceptible to radiation, and a spaceship would need to be designed with ample shielding to protect you. You might recall astronaut Scott Kelly, who spent a year in space. And even though the ISS is still within Earth's magnetic field, he reported complications due to radiation exposure. He wasn't completely protected. Too much radiation can lead to several forms of cancer. He reported vision loss, decrease in muscle mass. Astronauts on board the ISS regularly exercise They do so to prevent muscle atrophy. And another thing he reported was his skin grew quite sensitive and irritable from not touching many things while in space for a year. So what we can learn from this is the human body is just not used to operating in an environment without gravity. So a spaceship would likely need to contain some form of artificial gravity, not unlike those spinning tubes of the ship from the 2001 Space Odyssey. I've been talking about physical health, but mental health is just as important. We all got a taste of the effects from quarantine and isolation through the coronavirus pandemic. Now imagine a 2 to 3 year trip to Mars, or even a longer duration. Being cooped up on a small ship can raise stress. It can lower concentration and focus. It can create confusion. I saw a report a few years ago ranking the most likely causes of mission failure leading to death on a trip to Mars, and human error leading to a loss of air pressure on board either the ship or in a habitat on the planet's surface was the most likely. So I've been talking about space travel. Let's shift gears and talk a little bit about contacting other intelligent alien civilizations. SETI, or a form of the group, has been operating for close to 60 years now. And there hasn't been any clear or definite signal detected yet. However, we all know that on the timescale of the universe, 60 years might as well be 0. And we definitely need more time to search for signals. But let's talk about something called technological synchronicity. It basically states that the closer two intelligent civilizations are with respect to their technological advancement, are more likely to be able to communicate with each other. So, for example, imagine an intelligent species evolved on a planet 1,000 light years away, and they had the technology to send radio signals roughly 2,000 years ago. And they happened to point their signals toward Earth, which would take 1,000 years to reach us. Well, 1,000 years ago, we would not have had the technology to receive those signals. So maybe they have since met their demise, either due to a deadly meteor impact or climate change or nuclear war, whatever the case may be. They would not be able to continue sending their signals. So for any civilization, us included, it then becomes more of a problem on how to continue sending signals after you're gone, after you're dead or the planet's dead or what have you. If nothing else, but to just say, hey, we were here and we existed. There's a great Star Trek The Next Generation episode called Inner Light, where Captain Picard is scanned by a probe. And in time, I'm sorry, one second. I'm sorry, I'm at work and someone just walked in. Where was I? There's a Star Trek episode called Inner Light, where Captain Picard is scanned by a probe. And in the time of about 20 minutes, he thinks he has spent an entire lifetime on a dying alien planet, learning their culture and living as another civilization did. And basically the story was telling us that was their way of communicating long after they died and their planet died. So far, I've been talking about civilizations that are actively trying to send signals. Let me try to come up with a couple other examples. Imagine a planet, a couple of other examples of why a civilization may decide to not send signals or may never send signals. Imagine a planet similar to Earth with intelligent beings. However, their planet has little to no silicon. As a result, they don't invent glass, and in turn, they don't invent optics for telescopes. It's not unreasonable to assume then that they might not develop an interest in space and don't study it and don't try to send any signals. Another problem might be due to planet size. Earth is relatively small compared to other planets in our solar system and compared to some exoplanets that we've discovered. Earth has an escape velocity of about 250,000 miles per hour. So that's how fast something like a rocket needs to travel to get into orbit. So if an intelligent species evolved on a much bigger planet, it has a bigger radius, more gravity, they might not be able to develop rockets fast enough to get into orbit. So again, they might not be able to launch artificial satellites into orbit or send a rover to Mars, to a Mars-like planet like we do. And so they might, again, not develop an interest in studying space or actively sending out any kinds of signals. What I'd like to do now is share an image with you guys. It's an image that we sent out into space. Give me a second to share my screen here. Can you guys see that okay?
Yeah.
Okay, very good. So this was the Arecibo message. It was designed by Frank Drake and also with the help of Carl Sagan and a few others. The message was not really meant as a, it was meant more as a demonstration of our human technological achievement rather than any real serious attempt to enter into a conversation with extraterrestrials. It was aimed at the Hercules globular star cluster, also known as M13. M13 is approximately 25,000 light years from Earth. Traveling at the speed of light, again, that means it would take 25,000 years to arrive there. It was aimed right at the core of the globular cluster. And in 25,000 years, you know, the cluster is going to move a little bit. It's going to, but it's not going to move so great that it won't be able to reach the vicinity of the cluster. There's other stars in the cluster that it can reach, just not right at the very central core. But let's try to explain what this image is. Starting at, oh, let me just also state that the image was not sent with any kind of color like you see here. It's just color coded, so it makes it easier for you to understand. But what it is it's a binary message. It consists of 1,679 binary digits. It's approximately 210 bytes, transmitted at a frequency of 2,380 megahertz. It's modulated by shifting the frequency by 10 hertz with a power of 450 kilowatts. And the ones and zeros were transmitted by frequency shifting at the rate of 10 bits per second. And the total broadcast only lasted 3 minutes. So let me say that again, it only lasted 3 minutes. So when it does finally reach the globular cluster, if an alien civilization is not listening for a duration of 3 minutes at precisely the right time, they wouldn't get the message. But also, the message needs to be interpreted as 73 rows and 23 columns, and that's what each little square there is, 73 rows and 23 columns. And the first group at the very top, the white group, is just the numbers of 1 to 10. From the left to the right, if you look at those first two dots, actually you can ignore the bottom dots. The bottom dots just indicate where the number sequence begins. But from the very top, there's 2 black squares and 1 white square, and that's the number 1. And then you skip a column. In the next column, you have 1 black square, 1 white square, and another black square. And again, ignore the bottom square. So that's 0, 1, 0, and that's the number 2, and so forth all the way to the right through the number 10. I'm not going to explain everything in detail, but in purple, the next group down, those are supposed to be the atomic numbers of the elements hydrogen, carbon, nitrogen, oxygen, and phosphorus. And these are the elements that make up DNA. Continuing down, there's in the green group, these are the estimated number of DNA nucleotides. And the graphic below that in blue and white is supposed to represent the double helix structure of DNA. And as we continue down, you've got the little red guy there that's supposed to represent a picture of us humans. And continuing down in yellow, it's supposed to represent the solar system. You've got the sun on the far left, the big 3x3 square, and then you have Mercury, Venus, and then Earth is positioned up a little higher to represent that, hey, this is where the signal came from. And then it continues all the way out to Pluto. The next group down in purple and blue and white is supposed to represent the Arecibo telescope, radio telescope. But let me show you this next image here. You see that one? So I said earlier that it's supposed to be 73 rows by 23 columns. This is what the signal would look like if it was arranged as 23 rows by 73 columns. Loses a lot of its meaning. And so when we set this signal, we're kind of relying on the aliens who receive it to figure out how to decipher it all. The number 1679 is chosen as the product of 2 prime numbers, 73 and 23, and hopefully they will figure out that, hey, I need to arrange this by 73 rows and 23 columns. Here's what it looks like again back in the normal configuration, but it leaves it open to a lot of interpretation. Will another species be able to decipher that? I myself, looking at this, I don't know that I would be able to figure out that any of these things. So that is just being able to decipher a signal is another major problem with sending signals to another civilization. So I've really only touched on the most basic ideas here tonight. I could probably spend hours talking about it in more detail and probably deserves an actual full hour talk, but I'll leave you with this thought. Tim mentioned that the universe is trying to kill us. I'll mention that either by design or by coincidence, it really does seem as though the universe does not want intelligent civilizations to contact one another or to be able to travel outside of their own solar system. When you hear stories of UFOs or ancient aliens, and you think about all the challenges and difficulties that we've discussed tonight, or ones that you can think of, it makes you wonder how likely they are to be real. And but I would love to be proved wrong. And I'll leave you guys with that.
Thanks, Eric.
All right, awesome.
Questions of Eric on his topics?
Can I?
Yeah, go ahead, Mike.
Yeah, it was me. So first of all, You know, I would never put on a TV show my credit card information and my social security number. I've always had an issue with them not giving my permission to send that signal out into space. Just like maybe they'll come back and eat us or something. The other thing is, we should have just done it in English, because I've watched Star Trek and everybody on that show speaks English. Okay, that was stupid.
That is true. They always speak English, yeah.
Other unique perspectives and questions of Eric. All right.
Getting back to human survival in space. So another aspect, another physiological problem we have is a lot of astronauts report vision problems when they get back. And it's supposedly related, you know, the eye is a sack of fluid, and fluids behave differently in 0G, and they don't always come back normal. Have you run across anything in your studies, Eric, about the difference between men and women astronauts?
No, not really. I haven't really seen any articles delineating any differences between the sexes, but I would imagine there would be.
I visited Houston, and yeah, one of the medical centers there is researching this. And it turns out there's a theory that women are actually better suited for space travel than men. And the problem is men are tall and heavy, heavier on average, you know, than women. And this might be affecting why the fluid distribution gets so far out of whack, and that someone that's smaller and lighter won't have that great difference in how their fluids are distributed when they're weightless. But it's an area of ongoing research.
That's very interesting. I'll have to look more into that.
All right. Other questions or comments for Eric? All right, Tim, did you manage to get your video running?
I think I did. Let me give it a try if you're ready now.
Yeah, go ahead.
Okay.
Good audio, but no video. There you go.
Okay.
Way to go, Tim.
Hi, I'm planetary scientist Pascal Lee. As we prepare to return to the moon, one of the big decisions we're going to have to make is decide where to send humans. We might visit different sites, but also we might choose one where we would set up a base and stay there for the long term. I've been examining the lunar surface in more detail lately, and I think I might have found a really exciting place for humans to go explore and possibly settle. It's inside a large crater near the north pole of the moon. The crater is called Philolaus crater. It's named after the Greek philosopher Philolaus, who was actually the first to propose that the Earth might not be at the center of the universe. Anyway, let's talk more about why this site is so exciting.
4, 3, 2, I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
The Apollo program taught us a lot about the moon, and in particular about the origin of the Earth-Moon system. We now think that the moon was formed when an object about the size of Mars collided with the Earth very early in the Earth's history. And the impact was so violent that the incoming object was mostly destroyed, and in the process, a big chunk of the Earth's mantle and crust were thrown into space. All this debris was superheated and eventually formed a ring of debris around the Earth, which over time reaccreted into what we now call the moon. So the moon was born from this very fiery beginning, and because of that, it started off mostly devoid of water. So the moon is not completely devoid of water. We now know that there's water trapped in the minerals of the moon, and also relatively large amounts of ice in the polar regions of the moon. At the poles of the moon, you have areas that are permanently shadowed. They never see sunlight. And in these permanently shadowed areas, the temperature can be extremely low, typically minus 250 degrees Celsius. And so these places serve as traps, cold traps for water ice. And so that has been a big discovery, because being able to access water ice on the moon means that you can have water for hydration, but also use water in the future as rocket fuel. You can break down H2O into hydrogen and oxygen, and that's going to be rocket fuel that will cheapen your journeys to and fro the moon, and also out into the rest of the solar system. Now, the good news, therefore, is that there is water ice on the moon. The bad news is that it's going to be very hard to extract it at the lunar poles. This ice is buried in this gritty regolith, this soil, and so it's going to be very hard to extract. You're going to have to bulldoze tons of material to extract this ice. And then you're also going to have to operate in these permanently shadowed areas where you don't have access, easily at least, to solar power. And so how are you going to keep your equipment warm? How are you going to even power your equipment? This is going to be a challenge. And so if only we could find a cave in the lunar polar regions that could give us easier access to underground ice. So over the past few years, scientists have been finding at lower latitudes a number of unusual pits in the lunar surface. These pits are different from regular impact craters. They look like openings into underground caves. Many of these pits are found along these winding channels running across the lunar surface called sinuous rills. Sinuous rills are generally thought to be collapsed or partially collapsed lava tubes, which are underground tunnels that were once streams of flowing lava. The pits found along the sinuous rills are holes in the roof of these lava tubes, and for that reason, they're called skylights. Lava tube skylights are really amazing features on the moon because they represent access points into underground caverns. But of the over 200 pits identified up to this point, none are located in the moon's polar regions. And because of that, it's not clear if any of them would likely lead into lava tubes that contain ice. So to expand our prospects of finding ice on the moon, I became interested in the possibility of finding lava tubes and skylights in the polar regions of the moon. On Earth, when you have a lava tube in a very cold place, there's often massive ice sheltered inside the lava tube. On the moon, if lava tubes existed near the poles, temperatures inside these caverns might stay low enough to allow water ice, if it's present, to survive over very long periods of time. So I combed through hundreds of images of the polar regions of the moon taken by NASA's Lunar Reconnaissance Orbiter, looking for lava tubes and skylights. And incredibly, inside the crater Philolaus, near the North Pole of the moon, I spotted these intriguing small pits. Now, Philolaus crater is located at 72 degrees north, about 550 kilometers from the North Pole of the moon, on the moon's near side. The crater is outside the permanently shadowed areas of the lunar poles. Philolaus is large, approximately 70 kilometers across, and in the northeastern part of the crater, there's a relatively flat region that was once a pool of molten lava with these sinuous rills, in other words, collapsed lava tubes crisscrossing the surface. The intriguing pits I saw were located right along sections of these rills. The pits are small, typically 15 to 30 meters across, with completely shadowed interiors. This was really exciting because here I was staring at what might be the entrances to an underground network of lava tubes near the North Pole of the moon. So what are the next steps? Well, the first step will be to acquire higher resolution imaging to make sure that these pits are truly lava tube skylights. If we can confirm that they're lava tube skylights, then the next step will be to figure out if these lava tubes contain ice. And that actually is going to be a very exciting phase of exploration because that's going to take humans or robots on the ground. We're going to have to explore these lava tubes. And we're looking at a new generation of caving astronauts or spelunking robots to do this. And this whole idea of exploring caves on the moon is something that I actually grew up with as a childhood fantasy. Even Tintin and his dog Snowy, which were childhood heroes of mine, explored caves on the moon in which they found ice. Now, there are other aspects of the Philolaus crater site that I think are appealing. Number one, it's a relatively young crater. It's probably less than 1 billion years old. And this might sound old, but in a relative sense, compared to other things on the moon, it's actually relatively young. And so by exploring Philolaus crater, you get an opportunity to explore sort of the recent history of the moon and what has happened to its materials in recent times. The other thing, of course, is that when you are at Philolaus crater, you see the Earth, and that means that you can have direct communications with the Earth. You don't need a relay satellite. You just point your satellite dish to the Earth, and you have comms. So that's actually operationally a very practical advantage to have at a lunar site. And then the third aspect, I think that's appealing to me, at least, it's this, and it's almost icing on the cake, and that's the fact that you will have a beautiful view of the Earth from Philolaus crater. The Apollo landing sites were all near the equator of the moon. And that means that the Earth was essentially hanging almost right overhead for the astronauts, and they would have a hard time seeing the Earth. They would have to bend backwards in their suits to catch a quick glimpse of the Earth and then just continue on with their work. Here at Philolaus crater, the Earth will be hanging in the sky like a giant blue marble over the mountainous rim of the crater, just over the horizon towards the southeast, and it will just be an incredible sight to see the Earth from Philolaus. And then I'm intrigued by what lies ahead, farther ahead. Exploring the lava tubes of Philolaus crater on the moon will actually be a fantastic practice for exploring lava tubes on Mars in the future. And we know that there are lava tubes on Mars. We know that many of them have skylights. In fact, they are spectacular. And most of these lava tubes and skylights on Mars are found on the flanks of the giant volcanoes of Mars. These volcanoes are not erupting right now, but they might still be active and only dormant. And so maybe their interiors are still warm and cozy. Maybe there's moisture in there. Maybe these lava tubes on the flanks of the Martian volcanoes have ice in them and possibly even signs of life. So to me, there's this incredible prospect of really getting some practice exploring lava tubes on the moon to get ready for exploring and searching for life in lava tubes on Mars.
Wow, that was great, Tim. Thank you for sharing that.
Yeah, glad we got to see it. Right?
Yeah. Question.
Anybody ready to go to Mars?
Questions of Tim? Anybody have questions of Tim? No, that was a really cool video. That guy's really passionate about that, isn't he?
Yeah, well, he's the co-founder of the Mars Institute and SETI. So that's his passion is to explore the solar system.
Wow. All right. Any questions for any of our speakers, for Tim and Doug or Nihar or Eric?
I don't have a question. You hear me? Yeah. Hello?
Oh, we hear you.
Okay, so I don't have a question, but speaking of going to the moon, and both Tim and Dr. Lee mentioned about, turning water into jet fuel. Well, separating the hydrogen and oxygen from each other takes a lot of energy. And he, as Dr. Lee mentioned, at the polar caps, you don't get the solar power. So where do you get the energy? And the answer may be, I don't know how many of you have heard about this, but helium-3. It's an isotope of helium, and a number of countries are working on trying to get fusion reactors using helium-3. Now, helium-3 is very, very rare on Earth. It's created in the sun and carried on the solar winds, but for some reason, I don't know whether it's a magnetic field, the ionosphere, or just the atmosphere, prevents it from getting to Earth, but it is on the surface of the moon. They say it's mostly abundant on the gas giants, but it is in the surface of the moon. I don't know if anybody saw the movie about 10 years ago, this movie called Moon with Sam Rockwell. And Sam's job up on the moon was running these harvesters that harvested He3 from the moon's surface. Well, so I just think that'd be very interesting way of achieving the energy you need to separate the the oxygen and hydrogen from water. Just a comment.
Very good. Thank you, Jerry. That's very interesting. I'll look into that further.
Actually, I've got something to add there. Actually, I think it would actually just be easier to just create a whole bunch of solar arrays up on the moon. Even at the South Pole, up on the rims of the craters, you have sunlight. And especially at the South and North Pole, as long as these things pivoted, these solar panels could collect sunlight basically 365 days a year. You can probably generate a whole bunch of electricity. You build enough solar panels up on these the rims of these craters. Like I said, the sun would never set on some of them. Most of that stuff's we're probably gonna need to use robots on all of this stuff. We're probably gonna have to really be established before we send actual humans back for a very long period up there.
It was mentioned that dust is a problem on the moon, so I don't know if it would be a problem collecting on the solar panels.
Well, it would eventually. There's dust. There is a small amount of atmosphere. They say that at the Terminator line, when the sun comes up, it does create a small dust storm, but it's very small, nowhere near like Mars. I would assume that these solar panels would be years before they'd need to be cleaned off. And once again, I don't think if we're building nanobots to mine water or ice and other things on the moon, I don't think it would take that much engineering skill to create a nanobot to squeegee off the solar panels once every couple of years. It's simple stuff.
Other comments or questions for our speakers before I turn it over to Mike? All right, Mike, over to you.
I think, Tim, you have an announcement to make in memoriam.
Yes, we do. Let me share my screen one more time with you all. And so we just had a few announcements to make. I think you should be able to see my screen by now.
Yes.
Okay. So many of you may have heard that Nihar Jain has accepted the position as the Stockton Astronomy Society's first youth ambassador. So let's all give Nihar a round of applause or thumbs up.
All right, Nihar.
Yeah. We're really looking forward to our youth outreach, and this is kind of the start of it. So Nihar, really appreciate you taking on the position. And by the way, great presentation this evening. I think everybody enjoyed it very much. And last month, our presenter was Don Mockholtz, and I wanted to share with you his website there, donmockholtz.com, and then his Looking Up with Don podcast. I happened to catch a couple recent episodes of that podcast, and it is excellent. You guys really need to listen to it. It's like what's up in the night sky and interesting topics. I think you can also listen to it right off of that website. So try to look up either Don's website or that podcast. And then our program director, Fred Schumacher, has come up with these upcoming programs for SAS. Next month is Fred Lusk, our friend from the Central Valley Astronomers, is going to be doing a special presentation for our club. May 13th, Doug is working on a speaker from NASA Ames. So we'll confirm that. And then in June, we return to special presentations by club members, Jeff Baldwin, Rebecca Lewis, and Fred Schumacher. So we're looking forward to that. And then July 8th, Don Mockholtz returns with a program on comet hunting, which he is a true expert in the field on. So I'm looking forward to that July 8th. So those are the announcements, Mike, that I wanted to share with the members tonight. And maybe there's anything else that we have as announcements before we go to.
I have a commitment from Pranvira Hyseni from the Kosovo group. We haven't committed to a date yet, but she has promised she will give a presentation.
Okay, Jerry or Tim, do either of you want to make a statement of memoriam for Glenn, being that you know them?
Yeah, there we go. Just waiting for the poster to come up. So Glenn Mortensen passed away recently, and I wanted to share with you, Tim sent this to me. So this is the obituary written up by his family, and I've added a few things here and there. Glenn Howard Mortensen died of natural causes on 19 February 2021 at the age of 97. Glenn was born on 6 January 1924 in Benson Ward, Utah, and grew up in the farming communities of Logan and Richmond, Utah. After high school, he studied airplane mechanics at Utah State College. During World War II, he served as a corporal in the 8th Air Force at Royal Air Force Station Watton Air Depot in County Norfolk, England, where he inspected and directed repairs for B-17 bombers returning from missions over Europe. Now, many of those bombers couldn't make it back to the Force Station Watton Air Depot. They landed wherever they could, limp their way to. And so Glenn and his team got to travel all over the countryside to, look over the repairs of these bombers and get them back in shape. So we got to spend a lot of time in London besides his airbase experience. He was discharged at McClellan Air Force Base in Sacramento. With help from the GI Bill, he worked to put himself through college, beginning at Sacramento City College. He studied architecture. Architecture was a word he discovered while wandering through a dictionary while he was in London. He loved the buildings in London and whatnot. And when he came across the word architecture in the dictionary, he said, that looks like a pretty good deal. He studied architecture at the University of California at Berkeley, where he met Stockton native Carolyn Epperson, and they were married in 1949. After graduating in 1950, Glenn worked in the Bay Area as a draftsman. He received his state architect license in a few years, and in 1956, he joined the architectural firm of Mayo, Johnson, and DeWolf in Stockton. In 1962, he and Jack Holstein formed Mortensen and Holstein Architects, and some years later, he created his own firm, Glenn H. Mortensen Architect AIA. He later partnered with Gary Gideon to form Mortensen and Gideon Architects. So Glenn's designs of local homes, churches, banks, schools, and office buildings helped shape the image of Stockton and communities in the Central Valley and Sierra foothills. He was the primary architect for the Woodruff Regional Occupation Center, the Hunter Square Fountain, which has since been replaced by the most recent county courthouse, the School of Pharmacy at University of the Pacific, and most notably Burns Tower, also at University of the Pacific. So the Burns Tower project was commissioned in 1962 to build something that would conceal the water tower that was the once the water source for the school. Glenn designed it in a neo-Gothic style of old European buildings that he so admired while he was in England. He was very meticulous in every process. There's a lot of stained glass windows in Burns Tower, and he would pick out the pieces of glass himself, lay them out piece by piece in the on the ground before I put them up. The water tower itself, he had painted white. And this way, when the sun came in from the top and reflected off the tower, when you looked at the tower, it would look like it was glowing from the inside. He was an early proponent of alternative energy. Glenn designed the first solar home in Stockton in the 1970s. He presented City Hall with ideas for improving aesthetics and water quality at the head of the Stockton Channel and along Mormon Slough. He had some big ideas on what could have been done there. Glenn belonged to the Sierra Valley chapter of the American Institute of Architects, that's AIA, and was a commissioner for the Board of Architectural Examiners. He was active in North Stockton Kiwanis and the Stockton Engineers Club. He once proposed the idea at a meeting of the Stockton Engineers Club that San Francisco Bay could be dammed near the Golden Gate Bridge. This would help mitigate the effects of sea level rise in Stockton. And after desalinating the entire San Francisco Bay, it would help protect the Delta from saltwater intrusion, as well as providing drinking water for much of Northern California. Glenn had some really big ideas. He was also active in the Stockton Executive Club, the Solar Energy Society, and the American Legion. He was an active member of the Stockton Astronomical Society. When his vision weakened, he donated his iconic Celestron telescope, one of those orange C8s that we've seen around. Trevor Atkinson had one. There's an ad with Leonard Nimoy showing one off. So he donated his, which we still have and is in our collection, the Glenn H. Mortensen C8. He served a stint as our treasurer a while back. And at one of his first executive committee meetings, we were discussing the news that Delta College might level the Clever Planetarium, something, of course, they've done in the meantime. Glenn had lots of ideas on how we could build a planetarium, the Stockton Astronomical Society, and his feeling was that if you have big ideas, there's lots of ways to find the money. And so he was very optimistic and had big ideas. He was a big thinker. He was affiliated with the Stockton Fine Arts Gallery, the Cultural Heritage Board, and the Save Downtown Stockton Foundation Board, of which he was a founding member. Glenn and Carolyn shared a love of music. They were season ticket holders to the Stockton Symphony as well as the Stockton Civic Theater. Glenn sang for years in the Stockton Chorale and in the Barbershop Harmony Chorus. In addition to singing, he was an avid golfer well into his 80s. A highlight of his golfing days was hitting a hole-in-one at Stockton Golf Course, every golfer's dream. The family traveled by car throughout California and to national parks outside the state. After the children were grown, Glenn and Carolyn continued to travel to locations such as Alaska, Hawaii, New York, Europe, and Mexico. Glenn's hobbies also included woodworking, painting, baking bread, and in his later life, he even took up ukulele lessons. Of great pride was the home he designed in North Stockton and moved his family into in 1962. I've had the opportunity of visiting that home a couple times. It really was like going into a national park with this, very elegantly designed home. It's very nice. There, he could return to his origins by growing a large garden each year, planting fruit and nut trees, and harvesting the yield. Farmer Glenn had a strong work and self-sufficiency ethic. He could fix almost anything, it seemed, and he was keenly interested in technology and innovation. Glenn was a high priest in the Church of Jesus Christ of Latter-day Saints, where he also sang in the choir. In recent years, Glenn resided at O'Connor Woods and at Oakmont at Brookside. Glenn was a man of the greatest generation. He grew up poor during the Depression, served his country in World War II, and worked hard towards his goals. He had a limitless interest in the wonders of the world and curiosity about how things worked. A dear friend described him this way: he was a visionary who could see far beyond what is and made plans for what could be. He was honest and kind and lived by a moral code that never wavered. A gentle, kind soul among us for 50 years. Glenn was preceded in death in 2009 by Carolyn, his wife of 60 years. He is survived by children Dean Mortensen, Merritt Mortensen Bird, and Farrell Brosio. Grandchildren include Lisa, Eric, Kevin, Mark, and Anya, and 3 great-grandchildren, Elizabeth, Jonathan, and Melanie. His family will be holding a private burial with the United States Air Force Honor Guard at Cherokee Memorial Park in Lodi, and a celebration of Glenn's life will be announced at a later date.
Thank you, Jerry.
You're welcome.
Thank you. That was excellent. Well, we'll miss you, Glenn. Enjoy your architecture.
Yes.
Okay, let's see. What else do we have, Glenn? Anyone have any unfinished business? We do have the raffle if we have nothing else going on.
Can I add in a note here?
Oh, yes, Neil.
There's a message from the university today that there will be a sort of virtual celebration with various honors from the mayor and other dignitaries. I can forward that to anybody who'd be interested. I think it's something. I'm just checking my calendar to see if I've written anything down on it yet. I haven't.
I believe it's next Tuesday at 5:30 p.m. Oh, Gene Pearson.
You know anything more about it, Jerry?
It was supposed to be to celebrate Dr. Gene Pearson. I believe he's in geology. He has been on the faculty for 50 years. He's being recognized by the mayor and city council with an official commendation on Tuesday, March 23rd. Everyone's invited to a celebratory toast at 4:30 p.m. And it'll be live streamed from City Hall at 5:30. Yeah, I can share that information with anyone who is interested in attending that.
Good, thank you.
Oh, you're welcome.
All right.
Well, I am not sure, but I think Rebecca might have something to share with us.
Oh, yeah.
Oh yeah. Me and my spouse Joseph, we've both been accepted into graduate school.
Woohoo! Good job, Rebecca.
Was that the thing that I was supposed to announce?
Unless there's something else.
I'm a co-author on a SETI paper now.
Oh, awesome.
Good job.
There's that. But yeah, I'm going to be going for my PhD in astrophysics, and Joseph is going for theirs in geophysics.
Ah. He had to give you the hint because you forgot.
Which graduate school are you going to?
Yeah, we were we'll probably be going to UCLA that we were both accepted to into the graduate program. But we were both accepted into the same school, so.
Yes, very nice. Congratulations to both of you.
Rebecca.
Thank you.
I forget who the writer was, but he was talking about geology and geophysics, and he said that geology is just physics done really slow.
Oh, I'd make another bad pun, but I'm not going to.
Oh,
All right.
It was a science fiction author. I can't think of the book that was in. Anyway, congratulations to both of you. That is awesome.
And congratulations, Rebecca. That's awesome. Okay. Well, I'd like to thank our speakers tonight. Everyone did a beautiful job. I think Jeff here has the raffle name. So go for it, Jeff.
I never seem to win this. I actually don't. But Mike's got a Starbucks card, and our little competition thing, I roll the dice, I eliminate, and finally gets down to one person. The winner is John Forrest. You just won a Starbucks card.
Congratulations, John.
Oh, thank you.
Yeah. You need to send me your email. No, you need to send me your snail mail address, and you can send it to me on an email at baldjb@comcast.net. And I'll shoot it to you by email. Congratulations.
Thank you.
Thanks, Mike.
All right. So I guess this pretty much concludes our meeting. If there's anything else left, let's hear it. Otherwise, I'll declare it another successful meeting. All right.
Good night, everybody.
Good night,
Be safe.
all.
We'll see you in another month. And this is great. This was fun tonight. Thank you, gentlemen and ladies, whatever. Appreciate it. Good night.
Bye. Thank you, everybody. Great presentations.
Thank you. Paul, best of luck to you. Hope you come through that surgery.
Thank you.
With the rolling colors. Yeah, it'll be good.
Jeff, if you hold on for a minute, I can send you that email address.
Email address?
I can text it to you real quick here.
You mean the snail mail address I needed?
John Forrest.
Yeah, I need the snail mail.
Oh, snail mail?
So I can send them the prize.
I can just email it to you rather than type it into the thing here.
Yeah, just shoot it to me sometime.
Okay.
We there?
Mike, are we still on for tomorrow?
Yes. What time? Can I ask what time you're going to be off work?
I don't actually work tomorrow.
Okay.
Ooh.
See you at 5:30, something like that. I appreciate it.
Okay. I plan to get there around 5.
Perfect. Thank you. You're a lifesaver, believe it or not. I know you believe it.
You're muted, Bob. Bob, you're muted.
All right, I got back in and now the meeting's over. That worked out just fine.
I didn't notice how long you've been out there. I may have forgot to look.
Oh, well.
How long have you?
Yeah, that's pretty funny.
How long were you out of the meeting?
Whole meeting.
Because we're recording it. We can provide you the link to it.
All right, guys, we're off.
All right. Good evening.
Good night.
Take care.
So yeah, I was talking for about the last 10 minutes, so I wasn't monitoring the waiting room.
No.
Sorry about that.
No worries. It was my software is just freaking out over here for some reason. I'm not sure the VPN.
Well, I teach, so I'm used to people losing their internet connection all the time.
Okay.
Even I do. I had my computer crash twice in 15 minutes during a class.
Wow. Is that like, is Zoom have a problem or is it something else that's going on? Do you have any idea?
I don't know. It's stuff that happens, and I always have so much on my computer going on at the same time, and
I'm guilty of that as well.
Classes at the same time, so
yeah,
I think I'm definitely pushing it to its limits.
As you should.
There you go. There you go.
Yeah, I got a nice picture behind me in the meantime, so
I see that. Yeah,
it worked out for
That's
something.
going on.
Yeah, nice little a bell cluster of some sort. I don't know.
Yeah.
There's some good lensing in there.
Yep. Very good.
All right, we'll take it easy. See you next month.
So,
Bye-bye.
bye now.